All right, let's talk about derivatives of exponential functions. In some sense, this is the easiest section there is in calculus because the derivative of e to the x is just e to the x. So memorize this, but e to the x is a special function in that it's its own derivative. What that means, if we think about it, is when we graph e to the x, if you pick a y-coordinate along here, or if you pick any point, say right here where x is 0, the slope there is the same as the y-coordinate. Both of them are 1. If I wanted to, I could put in a tangent line at that point, and its slope would be 1, like that. If I wanted to put in a tangent line up here at, I'd say 2. Let's see, 2. Where is it? 2, 7 point something. Anyway, at 2 comma e squared, we've got that point, and its slope is also e squared. So e squared x plus something. I'm just going to kind of do this the cheap way and kind of slide it over there, plus this. So anyway, for any point that we pick, even if I put in the derivative f prime, notice they're the exact same. The reason for this is the further over we go, the steeper the thing gets, and the higher the y value gets. And this is just the function that works out where it's actually equal to its own derivative. If we put in something other than e to the x, like y equals, remember e is 2.71828, etc. If I put in y equals 3 to the x, notice that grows a little faster than e to the x. And its derivative is steeper. Let's make this g of x. So g of x is 3 to the x. Let's also graph g prime of x. See how the derivative is a little above the line, the curve? Now if I change this from 3 to 4 to the x, so I'm going to make it a to the x. Add a slider. All right. Notice for a while, the derivative is lower than the function. The derivative's here in red. Then later, the derivative is higher than the function. Well, if you go back here and you try to get them exactly the same, what you're going to do is you're going to zero in right on the number e. And the number e is 2.71828, 1828, and so on. So anyway, it's just the number that happens to work out for that. Let's do a couple of examples. These are going to be super easy. The derivative of f of x equals 3e to the x. Derivative of that is just 3e to the x. Derivative of 4e to the x minus x cubed is 4e to the x minus 3x squared. Let's switch back to Desmos for a second. I want to show you something. Let's go back and just put in 2 to the x. F of x equals 2 to the x. And f prime of x. what this is, if I graph y equals 2 to the x times ln x, times ln2, notice the black and purple graph are the same. So in general, if you take the derivative of a to the x, what you get is a to the x times ln a. And when you put in e for a, you get this, but ln of e is 1. All right. So that's pretty much all there is to that this section.